very happy to introduce James Watson here as our 2013 Peachman Lecturer. James was sworn in as the Director of the Bureau of Safety and Environmental Enforcement of the Department of Interior on December 1st, 2011, aka Bessie.
Right.
He is responsible for promoting safety, protecting the environment, and conserving resources through the vigorous regulatory oversight and enforcement of offshore operations on the U.S. Outer Continental Shelf. I don't have to explain to you how important a job that is, and I think you'll have an even deeper appreciation after our lecture today. Prior to his appointment as the Bureau Director, he served as the U.S. Coast Guard's Director of Prevention Policy for Marine Safety, Security, and Stewardship, where he was responsible for maritime investigations, quality traveling inspectors, waterway management, boating safety. Some of you here, I'm looking at you, Bob, where are you? Boating safety, yeah.
I'm hiding.
There he is. You've got to keep an eye on Bob. Boating safety and commercial vessel safety and security, and port and cargo safety and security. He served as a Deputy Commander of the Coast Guard Atlantic Area Command in April 2010, and on June 1st, 2010, was designated as the Federal On-Scene Coordinator for the government-wide response to the Deepwater Horizon oil spill in the Gulf of Mexico. Jim began his career as a cadet in the U.S. Coast Guard Academy in 1974. Upon graduation in 78, he received his commission as an ensign in the U.S. Coast Guard. Over the course of his 33-year active duty career, Jim attained the rank of Rear Admiral, serving in a variety of both management and operating positions in Washington, D.C., and at field units across the country. Okay. I have to add that in 1978, graduate of the Coast Guard Academy with a Bachelor of Science in Marine Engineering, he also earned Masters of Science degrees from U of M in 1985, and one in Mechanical Engineering and Naval Arc in both 85, so 2 master's degrees. In 2001, he graduated from the Industrial College of the Armed Forces with a master's degree in Strategic Studies. So I'm very happy that he's taken the time, I should add his personal time, vacation time, to come and speak to us today. So please give a warm welcome to Mr. Jim Watson.
Thank you, Steve. Thank you very much, and this really is an honor for me to come back to my alma mater here and talk a little bit about a lot of things. Steve basically gave me a blank sheet of paper, so I'll warn you up front, save some of your questions about some of the stuff in the resume, because I don't really have a whole lot of slides on the Deepwater Horizon or the different jobs specifically, but I can certainly answer questions on any of that. This is the outline of what I'd like to talk about. Little historical perspective, I think, that'll set the stage for what I want to get to near the end about observations and some challenges I think are exciting for folks like yourselves that are graduating and continuing to work in research in the marine technology area. But I'll go through a little bit on transportation, trade, resources, and energy, which is I'm very involved with right now. Get into some specific areas that I think are important for you all to know what is happening right now in marine transportation, offshore energy, and the Arctic. Say a few things about myself and about where I've been working, and then, as I mentioned, some challenges for the future that I think will hopefully tee up a good discussion here toward the end. So, this is my history slide. No Coast Guard officer can get through a slideshow like this without bringing up Alexander Hamilton, who actually was the founder of the Coast Guard. In those days, they called it the Revenue Cutter Service. But does anybody know what happened on June 20th, 1790? Actually, you know, the politics was just as difficult then, if not more so, than our politics today. But on that day, in fact, that evening, these two guys had dinner together. And at that point, they really didn't have too much alignment in their political philosophies. Alexander Hamilton was the finance, industry, sea trade guy. Jefferson was very much interested in sciences, natural resources, and the destiny of the United States to expand westward. But they also had some very important things that they had to get done as far as what they had to do politically. And for Alexander Hamilton, it was to assume the debts of the states from the Revolutionary War and create what we now have as treasury bonds and basically the financial basis of our country in terms of the Treasury Department and the Federal Reserve Bank, which didn't exist at the time. Jefferson really wanted that national capital in the South. At that time, they were up in New York. So the dinner was in New York. They went to dinner. They made the deal. Jefferson allowed Hamilton to move ahead with his first national bank and the assumption of the state's debts, which allowed the creation of our financial system that we have today. And Hamilton basically gave up New York City, his home city, from being the national capital to basically a bunch of farmland down on the Maryland-Virginia border. And I think, they had no idea what that would create, but in my opinion, what it did was it created the dynamics that have led to a lot of the wonderful things that we have today that stem from the combination of being a democracy and having that financial base and the technological drive that came out of that evening's dinner. That deal that was made, I think, has repeated itself over and over and over again in our history. One of the reasons I put this slide up was that they actually were able to build canals, and then the riverboat system, the Transcontinental Railroad. That's a Victory ship right there for World War II, the National Highway System, and of course the container system that we now have, shipping containers. And all of these things, I think, are representative of what we can do in America when we have the type of politics and the academic base and the financial well-being of our country to do it. In the resource and energy, what you have here is immediately sprang up a huge whaling industry, which was gigantic in its day, but short-lived. It evolved to coal. This is a coal steamer. You see the picture in the middle of the evolution of water power, generating mechanical power for the factories and ultimately electric power. And then here's your oil industry, the original coast of California, where they moved off into the Pacific Ocean there now, and then ultimately this is one of the first mobile offshore drilling rigs. So I believe that the maritime ventures of the 21st century more than ever reflect the visions and the practical decisions of our founding fathers. And I think that that just is a cool thing in my opinion, and we can talk about that more. But what I'd like to do now is to show you, I think, what is going on in the marine transportation system today. These pictures on the top, I think, illustrate what's happening in the world that is actually changing the marine transportation system in a significant way. The potential for new routes across the top of the world and the expansion of the Panama Canal. And that's going to necessarily involve ship design challenges, as well as ports and routes and safety challenges. And we'll get into that a little bit later. And the growth of the global economy, of course, has been driving the amount of cargo that is moving around the world. And you can, I know this isn't the greatest slide, but you can see that the dark columns next to the light columns on the left of each one of those is much higher in 2009 than it was in 2000, and those are TEUs of containers entering and leaving these various critical modal connections throughout the world. And here's some of the vessels that are out there right now, and we're seeing some innovative things. Certainly the size of tankers and container ships and cruise ships, but innovation and creativity in terms of propulsion and design. And I think that there are financial backers for these things. There are interests that will drive the need for designs and shipyards to be able to build things that have never been built before. So I think it's just a tremendously exciting time for the naval architects and the marine engineers. And then I'm just going to wind up with touching on the impact of the environmental concerns that will be a big factor as we look forward. In fact, right now, this is the current status of MARPOL Annex 6 and the amendments, as well as the EPA Clean Air Act environmental control areas. And it's basically to control NOx and SOx. And these are the dates that you're looking at. The first one for the North American environmental control area is actually kicking in just 2 years. So that is coming up really quick. The Caribbean environmental control area shortly after that. These pretty dramatic reductions in these emission levels to the point where I think designers and engineers need to look at an almost entirely different propulsion systems to achieve these goals. And then by 2020, we're looking at a global reduction. And so what are we seeing? We're seeing the use of LNG as a fuel. And this is pretty exciting. The TOTE has already negotiated some contracts for the construction of their container ships. This is the Harvey Gulf supply boat, and there's pretty well completed designs for smaller tugs. So I think you're going to see more and more of this. It is happening, and it's an exciting area for marine engineering. So let's take a look at offshore energy exploration and production. I've just thrown up a couple of pictures here, including the offshore wind. The state of that is developing in the United States, but it's already getting fairly far along in its advancement in Europe. We at the Department of Interior now have a pretty aggressive plan to put together a leasing program that will be available to entrepreneurs who want to put wind energy out into the outer continental shelf. And so you'll be seeing that in the next few years. It may start in the area where you can have designs that don't need to float, but it's just a matter of time before you'll actually need floating structures to hold the wind generator. What you have there is a floating production and storage and all-floating ship. And these are getting to be what you need as the industry heads further and further offshore. Which on your right there is your left, excuse me, is a production ship, and on the other side is a drilling ship, a modern drilling ship, the Discoverer Enterprise. And I put this slide in just to show you what is happening in the offshore oil and gas industry. First of all, the total offshore continues to go up, despite a lot of what you know about the United States and its discoveries on land of oil that can be fracked out of the source rocks, they call it. Which is an exciting new technology, and it's going to be wonderful for the United States. But worldwide, the search for oil is still moving further into the offshore from the onshore. And it continues to go up. What we're seeing is that the shallow water is getting depleted, and the growth is actually in the deep water. And what we find is that the really large reservoirs with high volumes and long lives is actually in the deep water, more so than ever before in terms of offshore oil reservoirs. The shallow water produce a lot, but not in the same quantities and volumes per day that the deep water reservoirs tend to produce. So that's your picture there of the trend. Here is the Gulf of Mexico in particular. What you see are the various types of facilities and their location. All of the colored facilities that you see are floating. So some are hubs, some are deep water facilities that act as a hub. Actually, I'm sorry about that. The green some of those are fixed, but they're servicing deep water production by being hubs where oil can be commingled from a number of the facilities that are on top of the wells, and then the oil is sent to production sites ashore. And you can see the red lines represent the pipelines that are out there. It's a tremendous infrastructure of pipelines to bring all this oil and gas ashore. In the Bureau of Safety and Environmental Enforcement, that's where the engineers are that work for the U.S. government that do the permitting for all of this activity, both for the drilling activity and for the production activity. So you can see we have one of the most highly developed offshore oil and gas fields in the world right here in the United States. And this is just one project. The Olympus, when it gets completed, will look like the picture on your right there. It actually looks pretty much like that already. It's down in Corpus Christi at the Kiewit facility down there. This is what the floating part of the platform looked like when it left Singapore. And the overall project looks like the diagram here on your left. The Olympus, the floating facility, it's basically, it is a tension leg platform, is moored in one location, and numerous wells, actually on multiple leases on the Outer Continental Shelf, will feed that facility. They'll separate the oil, the gas, and the water and send the products ashore on a transportation pipeline. But those are huge structures, and that's what you have to do in the deep water. All right, turning to Arctic. These are the Arctic countries. We're working actually very closely in something called the Arctic Council on what should be the concerns and the standards perhaps for that they can agree to for operating in both transportation-wise and oil and gas activity-wise, as well as just husbandry, basically conservation up in that area of the world. I have a few slides coming up that are going to show you a little bit about what the United States is doing, and I think that the leaders right now are the Russians, and if you look right in this particular area here, that's where some of the development is going on in Russia right now. There's actually already some activity out there, and some of the major international corporations are also starting to partner with the national oil companies in these areas. It's a huge amount of potential oil, but it's a very unforgiving environment in which to try to get it from. So there's huge challenges for naval architects and marine engineers there. As I mentioned, the Russian is to the stage where they're actually going to put this production unit out there. It will be floated. It is floated into place and then ballasted down to become a fixed platform that can withstand the movement of annual ice up in the Arctic area. So you can see the magnitude of these kinds of projects is just very, very large, and that's still in a relatively shallow area. In the United States and Canada, we're going to see the exploration is already in deeper areas than you could actually deploy a structure like that. This is a picture of Shell's drilling plan for last year. We permitted this out of the Bureau of Safety and Environmental Enforcement. It was just 2 drilling rigs, but it ended up to be a total of 26 vessels involved in the operation. They really have no organic infrastructure on the north slope of Alaska. So everything that they needed, they had to bring. So all of the anchoring handling vessels, their fuel tanker, anything they might need in the event of an oil spill, such as a skimmer vessel. And in fact, they weren't able to actually penetrate into the hydrocarbon-bearing areas during the season because they weren't able to complete the testing, the conversion of a barge and the testing of a system that was put on that barge that was designed to recover oil from the seabed to have a leak. This is equipment that is available in the Gulf of Mexico and other places in the world. It was not available in Alaska or even anywhere on the west coast of the United States, so it was a design and build project that didn't quite make the schedule. And then, as you know, they did have some challenges with the return of their equipment from the Arctic at the end of the season. Unfortunately, you know, the season is the fall. They really didn't get going until very late August, was when the final amount of last year's ice disappeared. This year's ice came in November. They successfully were able to get their equipment back down through the Bering Strait. They took on provisions and started a tow out of Dutch Harbor and got into a storm, and the Kullik, one of the drilling vessels that had drilled in the Beaufort Sea, was lost from its tug and ended up aground on Kodiak Island. So they're back in the yards now, actually both of the drilling ships. Here's a picture of them when they were leaving Seattle at the beginning of the summer. They went through some shipyard work in Seattle, and this vessel here, the Ivik, was actually the same vessel that was towing the Kullik, which is the one in the middle, when the incident occurred on the return. So now I want to shift a little bit about public service. That's what I've been doing. Maybe it's a little bit of a sales pitch, but I think, you know, it's important sometimes for, you know, you all, when you're in this stage of your life, to get a perspective on somebody who's sort of been through a career. And mine was public service. As you heard, I started out in the Coast Guard and ended up in Bessie. And so why did I do that? And I, you know, I've had some great experiences, and I think those things actually are of benefit to the government and to the industry and to the public. One of the things that I do is I look for people in history that I can sort of model myself and my ability to do things from the position that I have. And here's 3 guys that I actually think are pretty cool role models for me. One guy, Gifford Pinchot, was the guy that sort of invented conservation for the United States. He was a peer of Teddy Roosevelt, a younger peer, but Teddy actually had him found the U.S. Forest Service back in the days when the Department of Interior didn't do a very good job managing the lands with the forests and the natural resources, and so Roosevelt assigned that job to Pinchot, and I think actually he changed the future of America for how we manage our natural resources, particularly forests. lot of you probably have heard of George Marshall. I kind of look at him as a guy who was able to restore something that was pretty whacked out following World War II. And I feel that that's a little bit what I need to do in Bessie. We need to have a good plan, we need to have a vision, and we need to get a lot of people lined up in the same direction to achieve a goal. And I think there's nobody better than George Marshall to be my role model for that. And then finally, you know, I'm in the public health and safety business. All these thousands of people that are working offshore right now are sort of under my charge to not get themselves killed. And I don't know if you all have been around long enough to remember C. Everett Koop, but he made a big impression on me when he took on issues like, you know, public health issues like smoking and AIDS and those kinds of things, and actually was able to make a difference. And so, you know, it's just something to think about. If you go into public service, who's your role model? So I like to stand on the shoulders of Hamilton and Jefferson, look for some personal opportunity. I mean, it is personal. I've had lots of opportunities, and take advantage of them. Leverage the strength of the government and the industry to really achieve something good. And I think there's no richer opportunity in American history than what we have right now. And it's not just opportunities in the government. It certainly involves the entrepreneurial side as well as the financing side, but certainly in the policy side where I'm involved right now. So here's where I am, and it's probably no surprise that a bureau that was stood up just a year and a half ago actually got its origins from the tragedy in the Gulf of Mexico in 2010 when the Deepwater Horizon suffered the consequences of a blowout, and 11 people were killed, and certainly a huge environmental disaster. And the unit, this is a picture of it before it sank, but that was a big structure to go down in flames like that. So Bessie, I guess, has an opportunity to make a difference. And I think coming from my previous career in the Coast Guard, I think you could probably see that most of that history is written from a series of disasters as well. But in the case of Bessie, we do have engineers that have been working very, very hard, not only on the standards, but on the execution of the engineering that needs to go on before any of these new projects are allowed to operate. There actually was a moratorium in the Gulf of Mexico for several months in the deep water until some of these new standards and the ability of the industry to respond to those standards in their designs and in their equipment, in their applications was finally resolved. And so these are our offices. We have a large office in the Gulf. We have a smaller office in California. There still are oil producing platforms off the coast of California, and of course Alaska, where I showed you we had a lot of activity last summer. And this is just an example of one of the projects that's out there producing right now, Perdido. And I'll be going out to seeing that in just a few weeks. That's down near the Mexican border. Prior to that, there was my Coast Guard career. That, as I said, evolved since 1790, largely because of a bunch of tragedies. The modern Coast Guard itself was created in 1915, which was a direct result, really, of the Titanic disaster. This is a picture of the Sansonilla. That was in 1978 in Los Angeles, and there was an era when there was a lot of problems with tankers, not only due to the hydrocarbons and the explosive cargo problems, but as you know, the Exxon Valdez and navigational issues and you name it. So, Coast Guard put their nose to the grindstone. I was very much a part of that through most of the 80s and very proud of what was accomplished. This is the National Maritime Center. And what you see actually down there, those are not Coast Guard officers, those are merchant mariners. Those are merchant marine midshipmen. And I think we've come a long, long way in the evolution of our competency to operate vessels and design them, and also to provide services to them like navigational services and search and rescue services. And I wanted to throw this slide in here because of my experience here, and I think that does relate. You actually have to learn this to a certain extent, and you learn it while you're doing these courses and while you're taking the exams and while you're challenging. My big challenge when I was here was the finite element analysis work that I did, and it was hard enough just doing computers in those days, much less having to model a structure. And so I'm very proud to be a graduate of the University of Michigan, and I would say you're going to benefit from your experience as much or more so than me. So moving forward, you want to, these are just words of advice, choose something that really interests you. There's plenty to pick from out there. Specialize. You're going to need to specialize and problem solve. You know, it's something that I think you have to do no matter which career you're in, despite the fact that you might end up being a fairly general practitioner or even a policy guy like me. There was a period in time when I would spend a year, 2 years in a very narrow specialty, but it's paid off. Teamwork and project management. I think this is something that you can't find a better place than the University of Michigan to hone your skills at teamwork and project management. But certainly by the time you get to projects like this, that's really what it's all about. Accept new challenges. This was I had actually an experience of being told, you know, go do a stability test on the first passenger submarine. I had no clue, but I accepted the challenge. Went down to the Virgin Islands. That was tough, and we actually did an inclining test on a submarine down there. They're not like Navy subs. They actually do have to have certain stability characteristics. Be proud of your accomplishments. This is the first spherical tank LNG tanker that was built in Norway. And as a cadet, this is way back in the 70s, I went to Norway, and I actually worked in the yard that built this. It was shortly after this. And I'm very proud to say that you know, these tankers have had a perfect record of safety. And so I know it can be done. And so that's one of my big accomplishments, was I think being a part of the evolution, the development and the evolution of the safety standards and the compliance all the way till today for a whole class of what it could be a pretty catastrophic issue if anything does go wrong. This was the first tension leg platform in the Gulf of Mexico. I was involved with that too. I went over to Singapore and did a stability test on that. I guess once they figured I could do submarines, they threw me into the into the weeds on a TLP. But nowadays they wouldn't build the structure on the TLP in the same yard where the hull was built. But in those days they did the whole thing over there, and it could be inclined before it was shipped. I wanted to show this one as a be ready for anything. This was the Macondo event. This was the blowout in a couple of different phases, actually late in the event, because this was after they cut off most of the riser, had a little section of it sticking out, and you could see the full flow of the blowout coming right through the top of the BOP and into that little section of riser that remained. The amazing thing about that event was the ability of engineers to start from scratch, just whiteboards, and design and build this blowout, this capping stack that eventually capped that well. There had been nothing like that envisioned. So it was a marvel of design, engineering, building, and operations. The picture in the upper right there is after the capping stack is on the well. They've closed down the major valve, the big valve that would shut in the well flow right straight through it, and now they're only remaining one valve to close before the entire well is shut in. And the reason that you want to do it in a kind of a sequence like that is that everybody was very, very concerned about the structure of the well below the seabed. And as they were shutting these valves down in sequence, they were very closely monitoring the pressures and trying to get a sense as if there was any possibility that oil would breach through the sides of the well below the blowout preventer. And of course it didn't, and eventually they filled that whole well up with cement. But this is what the structure looked like. This is the size of a person, so this is a very big thing. And now we have a small fleet of these capping stacks ready to go, including on the West Coast. And this was the converted barge that I mentioned that did not make it to the Arctic last year, but it should be ready to go the next time Shell goes up there. And its purpose is really to be able to, in the event that the well that needs to be capped cannot be capped because of the internal structure of the well not being able to sustain this shut-in pressure, this barge will be able to take that flow of oil, gas, and water and receive it. Normal drilling operations, they don't bring a production capability with them to the drilling area. And in the Gulf of Mexico, again, because there's production units out there, you can depend on somebody providing that when you need it. In the Arctic, you have to bring it yourself, and that's Shell's unit there. And it comes also with a dome that can be set on the seabed if there is a breach, or perhaps on a pipeline, or maybe even on the top of a blowout preventer to receive the oil before it actually floats to the surface. And it's a lot better method of doing oil recovery than using a skimmer and boom on the surface. And that's my last slide. I just love this place.